Today we're going to look at Microsoft Visual C++ 2010 Express. This is a free program from Microsoft. There's absolutely no cost to it. They do ask you to register, but that's not a big deal. There is no cost to this program. You can just download it from the Microsoft website. Now, the first thing you want to do when you get into Visual Studio Express is create a project. You do that by going to File, New, Project. And we're interested today, since we're doing some assembly language programming, in a Win32 console application. So click on Win32 console application. Type in a name for the application, which we'll call ASM, and click OK. So this is going to set up everything needed for the console application. You can just click Finish. Now, what a project is, a project contains all the files necessary to assemble compile and assemble a program. Now, what we have here, this is the Solution Explorer. It contains all the files related to the project. Over here is the actual. It actually sets up a program, a file called asm.cpp. And while you can assemble assembly language programs in Visual Studio, turns out it's much faster, simpler to just use C++ and do what we call inline assembly language programming. So now we have to set up a couple of things in here when you first install Visual Studio 2010 Express. The defaults are some very simple settings. It's set to basic settings, so we want to say, so we'll go to Tools, Settings, and go to Expert Settings. That allows you to, that opens up a number of other windows that you'll need for what we're going to look at. Okay, so what I'm going to do here is put in some inline assembly language. And the way you do that is you do __ASM and surround that by braces, and then put everything inside of that. So this is exactly what that looks like. So it's __ASM, and there's braces around the actual assembly language code. Now, what we need to do then is we can actually compile this, or actually execute it. You can see down here in the output window, it's going through the process of assembling that. Now, we also want to go ahead and debug this. So we're going to click on Debug, and we're going to say Step Into. Now, that starts as the first line of the program, and also what gets opened up here is this toolbar. This is some debugging, and the things that you're probably going to be interested in are the Step Into and the Step Over. We probably won't cover today. These are used for function calls. Also, Stop debugging is well, that's how you stop debugging. Another thing that you're going to need here is to set up the output windows. Now, we're going to want to have a memory window open, and so as you can see, I wanted to debug Windows. Another thing you're interested in here is the register window. Now, you can actually take these windows and you can move them around and use this control. You put the mouse over it, and it allows you to subdivide windows and like I said, move these things around almost anywhere you'd like. Also, here in this register window, there are other registers available. You can turn on and off flags. You can turn on and off floating point registers. But for today, we're not going to be using that, so we just need these few basic registers. Okay, so now we're going to start actually debugging a program. And what you'll notice is there's going to be changes in the register window. Those will be highlighted in red. So let's see. This is the actual first line of the program. And you'll notice here that the EIP register is the only thing that's changing. That increments at every single operation. That points to the location of the instruction that we're currently executing. So as we step through this, there's been no changes except to the EIP. So what these no-ops are doing is, no-op is short for no operation. So they actually don't do anything. But as you can see, the EIP instruction does increment. Now we're getting to the move instruction. The move, so the way this works is move. It's going to say move to the EAX register. This hexadecimal 8Fs. And as you can see, when we step into that, the EAX register gets set to 8Fs, which is now the way these registers work is the E is short for extended, and the AX is a particular general purpose register on an an Intel processor. So the EAX just got filled completely with Fs. Now the AL was original to the original 8088 assembly language. And that's the L stands for lower, so that's the lower, the lowest, the least significant value, the lowest byte on that register. The AH is this actually stands for high, but in this case it's only the second byte in the register. Now the AX actually is that whole 16-bit register. So AL is the lower 8 bits, the AH is the upper 8 bits, and the AX is the full 16-bit register. And as you can see, what we're doing is we're moving the value 2 into that register. Now the EAX is as I mentioned earlier, the extended register. So that is 32-bit, a 32-bit register. Now we're going to be moving a 2. As you can see down here, the whole register is replaced with the value of 2. Now, if you're talking 64-bit registers, that this instruction would be move RAX, and that would allow you to address a 64-bit register. That's all we have for today.